In this video, we shall look at some of the steps that we can take to introduce inheritance into an existing project. For this exploration, we shall use version 1 of the network project. These steps will be the first of those that we used in the book to create version 2 of the network project from version 1. In the course of this refactoring, we shall introduce the terms superclass and subclass. We've seen that one of the problems with version 1 of the network project is the large amount of duplication in the post classes. The solution that inheritance offers is to place the duplicate code in a separate class that is shared in a special way by the old classes. In object orientation, this new class is described as a superclass, and the old classes will become subclasses. In this copy of version 1 of the network project, we've already created an outline superclass which we've called post. The comment at the start indicates that this class will store the shared functionality of the other post classes. Rather than immediately moving all of the duplicate code to the superclass, we shall start with the small step of moving just the timestamp field, which both message post and photo post have. This is in keeping with our principle of making relatively modest changes when refactoring, in order to reduce the risk of introducing errors that are hard to find. We note that timestamp is declared, initialized, and used identically in the two classes, so it's an obvious case for factoring out. We'll use the message post class as the source for the code to be removed, and then edit the photo post class afterwards. First, we cut and paste the field. Next, we cut and paste the initialization. Note that we're in the process of creating just a regular class, so we could compile it at any time to check that we haven't introduced an error. This illustrates the fact that superclasses are just ordinary classes, with fields, constructors and methods as we're used to seeing. However, because we're taking message post apart, we could not compile it successfully at this point. The methods still refer to the timestamp field that has been removed, so message post is not yet a proper subclass. So let's move the getTimestampAccessor method to the post class, and we shall then be in a position to make message post a proper subclass of post. If we try to compile message post now, the compiler tells us that it cannot find the variable timestamp. This is reasonable because we've moved it to a separate class and it's no longer in message post. But we know that this field really belongs as part of a message post, so we need to find a way to indicate that the message post and post classes are related in a special way, so that message post objects will have a timestamp field. If we switch to the class diagram, we see to the left two boxes with arrows. In the class diagrams we've seen up to this point, the upper dashed arrow is the one that has been used exclusively. We're now going to introduce the lower one that has an enclosed arrowhead. This is used in a class diagram to indicate that two classes are related to one another by inheritance. If we select the arrow, then click on the would-be subclass message post, and then on the superclass post, the arrow is drawn. Furthermore, if we look in the source of the message post class, we see that the class header has been enhanced with something new, extends post. This is the Java syntax to indicate that message post is a subclass of post. In other words, message post objects will possess all the fields and functionality of the message post class and the fields and functionalities of the post class. Note that this does not mean that a message post object somehow stores a separate post object. It means instead that the message post class is really a composite of everything in its own definition and everything in the post class. That is what the extends keyword means that's been added to the header. There will be some subtleties to explore about this relationship, but this is in essence what inheritance means. So let's try compiling having made this change. Once again we get an error in message post display method where it tries to use timestamp, so we don't appear to have fixed anything. However, the error we get this time is actually different. Let's check that. If we go back to the version that does not use inheritance, the error is cannot find symbol variable timestamp. Now the error with inheritance. Notice that we can simply type the code that BlueJ put in for us rather than drawing the arrow on the class diagram again. Now when we compile, the error is timestamp has private access in post. This is a significant difference. The compiler recognizes that timestamp is actually a part of the message post class through inheritance, but the message post part of the class is not allowed to access it because it's been declared as private in post. This simply confirms the rule we've seen previously, that private items in a class can only be accessed from code within that class. Inheritance hasn't changed that rule, but it seems to make life inconvenient for us because we want the timestamp field to be part of message post. Maybe we should loosen the visibility of the field in post so that methods in message post can get at it. The problem is that the field would then become visible to other classes as well, and we don't really want that because it weakens the encapsulation. In fact, there is a straightforward solution. Recall that we have an accessor method in the post class. Methods are inherited from a superclass just like fields are. The getTimestamp method is public, so it will be accessible within the message post class. So we replace the direct access to the inaccessible field with a call to the getTimestamp method. Notice that we don't need a special syntax to call an inherited method. The method is called just like a local method would be. Now the message post class compiles. We can even create a message post object, and the inspector for it looks just like before. There is the timestamp field. Notice though that the getTimestamp method does not appear to be among message post's list of methods. However, if we move to the top of the list, we see inherited from post, which is where we find it. This is just the way that BlueJ presents us with the list of available methods. Within a program, the inherited methods of an object are called no differently from the other methods. Indeed, it's not actually possible to distinguish between superclass and subclass methods from outside an object. All that remains at this stage of the refactoring is to apply similar changes to the photopost class. This time the changes are simpler, however, because all the work's already been done to create post. We just have to add the inheritance arrow on the diagram, delete the timestamp field, its initialization, the getTimestamp method, and finally insert the call to getTimestamp. And the project compiles once again. Notice that no changes were made to the newsfeed class. This reflects what we said earlier. The external view of a subclass is no different from what it was before. The newsfeed class is not even aware that anything has changed about the message post and photopost classes. However, the fact that we shall be able to remove most of the duplication in message post and photopost means that we should be able to take advantage of that in the newsfeed class, but that's covered in the chapter. In summary, we introduced the terminology superclass and subclass in order to make distinctions between classes in an inheritance relationship. We saw that the class diagram is able to show that an inheritance relationship exists between classes. Java uses the extends keyword to indicate that one class is a subclass of another. An object of a subclass contains all the fields and methods of its superclass, as well as those of the subclass. The rules on private access continue to apply between a subclass and its superclass. Inherited methods are called from within the subclass as if they had been defined locally.